Welcome to Harburn Double O. Indeed, welcome back to Harburn Double O. It's a rare day in Scotland. We've got some sunshine. For February, it's not too bad. So, the last video, I took you through this DCC accessory decoder for the doors and the engine shed. Today, I'm going to take you through the DCC sound part using this board here and also another board under here. This little soundboard here. Okay, so it has got a SD card in it as well, and got speakers sitting here. Should note that the optocoupler for the signal from the DCC track to this here also feeds this one here. There's no need for two optocouplers for the full shed. It can do several DCC decoders. So I'll let you hear the sounds first here, folks. First one's going to be the door alarm. Turn the power on. That's door alarm. Next one, it's a little well one. Now, I have got the capability to put an LED on that as well. At the moment, I've slowly wired it up. That's a little grinder. Dog barking. And another welder. So I can put quite a few sounds on it, folks. That little card can take thousands of sounds as such, but I've only put the 5 in to start off with. So I'll take it over to the PC and let you see the coding for it. This is the board here, folks, the little soundboard, the DYSV5W. There is various types of boards there. The W means it's writable on the SD card. Goes in here. Of course, you need an SD card as well for it. But for the price of £3.34, it's not too bad. They were a bit cheaper a couple of years back, but the price of everything has went ballistic here. So that's the little board for connecting to this DYSV5W. I'll call it from now on the soundboard. This is the code here, folks. There's a little description up here, just defines it. You'll notice that the sounds are not quite in order. I've put them in because I've been tweaking with the codes as we go. It's quite important how you remember the codes. The sounds here is 00, and then 1, 2, 3, and so on. If you change one sound, I've found you're best changing all the sounds or renumbering them all and put them onto the SD card from scratch. With the sounds, you can find them on the internet, folks. Even the BBC has got a sound website as well, where you can download various items of noise, as they say. Okay, so in the main part of the code, and then we've got to include the NMRADCC. This is to decode the DCC packets from the track coming from the optocoupler. Also include software serial. That's because you're using the serial device to attach the sound module to the Nano. The pin definitions there, we've got DCC pin number 2, so optocoupler, it goes to pin 2 on the Nano. The weld LED pin 9, I've still put the LED on it, and also I need a resistor as well. Even though it's 5 volts, you'll still need a little resistor with it. Then we've got our RX and TX pins. Pin 10 on pin 11 on the Nano goes to the sound module. The debugging, what I should say there, the RX goes to the TX on the sound module and the TX goes to the RX on the sound module. We've got a bit of debugging put in here as well. This is to enable the programming it to fine tune, as I say. If you're not wanting debugging there, you just set these to false rather than true, so you can bypass it on your serial monitor. We've then got the decoder settings. Each sound effect is triggered by its own unique DCC address. So I've put on the addresses for the warning sign for the door, for example, 80, the air tools 82, the door bark 84. I've also put in an all stop 85, so we can stop all sounds with this as well. Pretty good if you've got a big long soundtrack, i.e. a bit of ambience noise in the background playing for about 2 hours, and you want to stop it after 10 minutes, you could hit this address here and it'll stop. And the soundtrack numbers 1, 2, 3, 4, 5. So say again, it's not quite in the order that I've got them on set up there now. I've got to be changed a little touch. Next, we've got to create the objects there. So we create the DCC handling, we create the software serial port for communication with sound module as well. Then we've got the welding effect here, folks. We'll set the variables for the welding effects. We can set the duration here, how long you want to take here, welding to go on there. The same again, you could add rise and fall here as well. So if you're using a variety of LEDs, you could have a white one for the flashing and a red one for the cooling down of the weld. If you wanted to, I just went for the flashing flicker for 7 seconds, folks. Next, we'll what the track actually is playing there. So it stores the track number currently playing, the sound. I say again, no sound playing, it puts in the 0. Then we've got non-blocking time variables there. It's quite important you don't use delay in here. You also use mils for your non-blocking timing. If you put a delay in there, you press the button, it'll play a song and it won't play anything else until that song or sound has finished. Then you get a DCC monitoring, it just monitors looking for the address. If it finds the address, it'll go into it itself. And again, we've got a little bit of debug helping here. Look at the last periodic status message printing the serial there, and 12 milliseconds to print the report. So it's got 10,000 milliseconds put in here. So again, it's not a delay, it's milliseconds. Next, we've got a helper function that prints out the formatted debug messages there. So it prints out what's happening, if the lights flashing, if the sound's playing. Then we've got our DCC callback fired, an output address mode, accessory packet is received. So once it receives it, it prints it out saying you received a sound, and you're going to play the sound as well. Then you get your DCC callback fired, the board is addressed in mode, a packet is received, it goes and tells it what to do with that packet. I've got them set up as momentary triggers, so it's not like you've got to press it and hold it again to release it and then hold it again. You just press it once, let go, it'll do the trigger. So that's what you call a momentary trigger, rather than like your points. You throw your points across, they're thrown across, and it'll stay there until you throw them back to close. This one here, you throw the switch, it's only a momentary switch, it switches itself back off again. Hope that comes clear there, folks. We've then got to convert the board addresses, output pairs, and similar absolute accessory addresses as well. The same again, a little bit of debugging there. We print out some labels and calculate addresses, etc. And I've got the output there, all active output power is on, ignore the off commands. So again there, that's the momentary triggers there, folks. Then you get your common address handlers, going down there for your door, your welding, your air, your grinding, the dog barking, stop one as well. Then we've got our setup there, the start serial address for the debug on your serial monitor. It is linked to the DCC shed control as well there, version 1. I did plan on using wind Nano for doing both sound and doors. It is possible, folks, it is possible there, but I was running out of pins once I put all the sensors, etc. with it. I suppose I could have went into the ESP32 route or maybe the Pi cow version as well there. So again, there's just a little bit of debugging going through it there, folks. So it sets the welding pin up, sets the DCC input pin, turn on pull-up resistors is enabled as well, and then it tells the NRA library what interrupt number is and what pin to use to activate the high. And then it goes through all your flag outputs addresses as well. I say again, we've got a bit more serial printing, so when it does the sound in the monitor, I'll print out dog, print out alarm, etc. with it. And we'll go the mils again there, folks. Record the current time at the start of each first initial step, and it starts at 0, and mark the system if not yet ready, it's false. Then running the basic loop with it, so it constantly looks out for a signal. If the signal is received, it'll start to play the sound or even as well with it. So we've got case scenarios in here, 0, it waits 1000 milliseconds for the power to stabilise, and then I'll go through the actual function it's going to do for each case scenario. Then you've got your DCC process, must be called every loop, processes any received DCC packets and first callbacks. Your welding flicker effects runs continuous while welding active. So if you find the welding activity is finished and the sound's still playing there, 7,000 or 7 seconds, I should say, that you might be able to tweak that number. Your periodic status report printed the serial monitoring. So let's just a bit of monitoring tap here for folks. I could take out the debug once I'm happy with it, but at the moment I'm still tinkering with it, folks, here, so I've left it in the moment. So your handler for your doorbells, your handler for your LED effect there, your handler for your ear tools, your handler for your grinding sound, your handler for the dog barking, and your handler for all stop command. Sends a play specific track command to the sounds audio module over the serial track, the TX and the RX. And this is the commands that sends it to you there, folks. It's all in hex format. If you want it to play a different sound, you need to go to the hex there and put that number in. Or as I do, get somebody to help me with like ChatGPT or Claude. Not as much ChatGPT now. I fell out a little touch. I find Claude is far better at coding for us. And if it's got a stop playback command, DCCA or DYSV5 sound module will stop all the sounds. And it's going to debugging as well there, folks. And that's the code. Once again there, if you want the code there, folks, just drop me an email, harburn00@gmail.com. I'm more than happy to send this code over to you. Hope you enjoyed this, folks. I'll hopefully see you in the near future there in the process of a new PC. It's due to come today. Postman back and get out his sack, as we say. So I hope you liked it there, folks. We've reached 1,000 subscribers. Thank you very much for that. And I hope you notice up here I've called this program Subscribe. So all the best there, folks. Thanks for watching. Leave a like, leave a comment. And if you want the code, drop me an email. Cheers.